Hello again. We are continuing our discussion of exponents and exponential functions by talking about how to divide powers and exponents and things like that. So let's get started. Let's look for a pattern by looking at some examples. If I have x to the 7 divided by x to the 2, x to the 7 is 7 x's being multiplied together, and x to the 2 is 2 x's being multiplied by each other. So that's how I'm going to write it, by separating it out and expanding it. So what I'm going to do now that I have a fraction is I'm going to look for any common factors that are in the numerator and the denominator, and I'm going to cancel them out. And if I look carefully, I've got 2 x's on top that can be canceled with 2 x's on the bottom. And that leaves me with only 5 x's being multiplied together, so I can write that as x to the 5th. All right, let's try k to the 9 divided by k to the 3rd. K to the 9 is 9 k's being multiplied by each other, and k to the 3rd is 3 k's being multiplied by each other. And if I notice, I've got 3 k's in common with the top and the bottom, all being multiplied, so I can cancel them out as common factors. And that leaves me with 6 k's being multiplied together on the top, which is k to the 6. So hopefully we can see a pattern. When we're dividing powers that have the same base, we're going to subtract the exponents. So let's look at some more examples. If I have w to the 7 divided by w to the 5th, my answer is going to be w to the 7 minus 5, which is just w to the 2. It also works with negative exponents. If I have p to the 7 divided by p to the negative 3, that's going to be p to the 7 minus negative 3, which is p to the 10. It works with terms with many variables. You just have to work one variable at a time. So if I have a squared, b to the negative 5, and I'm dividing that by a to the negative 8, b to the negative 2, I'm going to look at the a's separately. So a to the 2 divided by a to the negative 8 is a to the 2 minus negative 8, and that is a to the 10. And then b to the negative 5 divided by b to the negative 2 is b to the negative 5 minus negative 2, which is b to the negative 3. You still have to multiply the coefficients, though, or divide them, whatever the case may be. So if I have 18x to the 6, y to the 6, z to the 6, and I divide that by 2, x to the 3rd, y squared, z to the negative 1, the 18 divided by 2 is still going to give me 9. X to the 6 divided by x to the 3 is going to give me x to the 6 minus 3, which is x to the 3. Y to the 6 divided by y to the 2 is going to give me y to the 6 minus 2, which is y to the 4. And z to the 6 divided by z to the negative 1 is going to give me z to the 6 minus negative 1, which is z to the 7. Okay, let's look at some examples that have exponents in them. If I have d to the 5 over d to the 2 and I'm raising that to the 7, I'm going to simplify what's in the parentheses first. So d to the 5 divided by d to the 2 is actually d to the 5 minus 2, which is d to the 3. Now I can raise that to the 7, and remembering what I learned in the last lesson, d to the 3 to the 7 is d to the 3 times 7, which is d to the 21. This also works with negative exponents. So if I have v to the 9 raised to the negative 3, and that's being divided by v to the negative 4, if I remember from the last lesson, v to the 9 to the negative 3 is the same thing as v to the negative 27 by multiplying the 9 and the negative 3. Leave that over v to the negative 4, and now I can subtract the exponents. V to the negative 27 divided by v to the negative 4 is v to the negative 27 minus negative 4, which is v to the negative 23. I have a negative exponent, so I can write that as a positive exponent by putting it at the bottom of a fraction, which I've done. This is v to 1 over v to the positive 23. Okay, it works with terms with many variables. So what I can do is just look at all of that and work with the f's separately and the g's separately. So the first thing I'm going to do is I'm going to simplify the top. So I have f to the 3, g to the negative 4, all raised to the negative 8. So f to the 3 to the negative 8 is going to be f to the 3 times negative 8, which is f to the negative 24. G to the negative 4 to the negative 8 is going to be g to the negative 4 times negative 8, which is g to the positive 32. And then I leave the denominator the same. Now I can divide. F to the negative 24 divided by f to the 6 is f to the negative 24 minus 6, which is f to the negative 30. And then g to the 32 divided by g to the 19 is g to the 32 minus 19, which is g to the 13. And since the f has a negative exponent, I can move that to the bottom of the fraction and make that f to the positive 30 on the bottom of the fraction. G to the 13 is fine. It has a positive exponent, so I will leave that where it is. I still have to raise coefficients to exponents, though, even when I'm dividing. So if I have 2x to the 5th, y, z to the negative 3, all being raised to the 5th, and then on the bottom I have 3x squared, y squared, z to the negative 1, all being raised to the 3rd, then looking just at the top, 2 to the 5th is 32. X to the 5th is x to the 25th. Y to the 5th is y to the 5th. Z to the negative 3 to the 5th is z to the negative 15. Then looking at the bottom, 3 to the 3rd is 27. X squared to the 3rd is x to the 6. Y squared to the 3rd is y to the 6. And z to the negative 1 to the 3rd is z to the negative 3. Okay, so now I can't divide the 32 and the 27 because they have no common factors. So I'll leave the 32 on top and the 27 on the bottom. X to the 25 divided by x to the 6 is x to the 25 minus 6, which is x to the 19. Y to the 5th divided by y to the 6 is y to the 5 minus 6, which is y to the negative 1. Z to the negative 15 divided by z to the negative 3rd is z to the negative 15 minus negative 3, so that is z to the negative 12. I've got x being raised to a positive exponent, so I will leave that on the top of the fraction. But y to the negative 1 can be moved to the bottom to be y to the positive 1, or just y, and z to the negative 12 can be moved to the bottom of the fraction where it becomes z to the 12. So that is hopefully enough examples of dividing with exponents. If you have any questions, please let me know, and I will see you tomorrow.